Okay, right. So we'll go through the question first. Right. So remember this. So when you're answering a question like this, like where you have to read a description and then you have to come up with a diagram or answer some questions, what you can do is while you read the description, you take a note. Like, if it is a use case diagram, you need to identify who are the actors and what are the um, operations those actors will be performing in the system, right? And that you will be drawing in the diagram. So therefore, when you read the description, it's better if you can take a short note like, okay, this is the actor and these are the operations that the actor is performing. Then it will be easy for you to draw the diagram. Okay, right. So I'll give you like 4 minutes. Can you all just roughly go through the description once again? So to like to revise what the question is about. Can you do that? Word document first. Okay, right. So the use case name is drug purchase. Sorry, purchase drug. Right, actor. Yeah. So the actor will be patient. Okay, and yes, precondition. The drug should be displayed on the screen, and also you can take the patient has coins, right? Because it says before purchasing the drug, the patient has to have the drugs with him. Okay, so we say on the screen, and the patient has coins. Goal is to purchase a drug. So typical course of actions. So the use case will start when the patient select the drug and the quantity from the touch screen. So you can type the first step. The use case starts when the patient select the drug and the quantity. So if you want, you can have it as 2 steps. You can say use case starts when the patient select the drug, and then second step you can say the patient select the quantity, or you can put both together and write it as 1 step. Okay. And then what the machine will do is when the user select the drug, the machine will calculate and display the amount to pay. right? And then what we have, if the machine does not have sufficient stock, it will display out of stock. So are we going to write that as the main course of actions? So the uh, machine displaying out of stock, are we going to write it as the main course of actions? Yeah, so it is going to be an alternative course. So in the use case scenario, we are writing the best case, that is everything goes right? So the user enter this drug amount and the drug, and the system display the total amount. Then what's happening? The patient can enter there's a quantity that's alternative. Um, so after displaying the amount, the patient can enter coins. So that is going to be the third step. Patient enter coins, right? When each coin is entered, the machine will display the balance to be paid, right? Yeah. So that is going to be the fourth step. Step number 4, display the balance to pay. Okay, then once a patient enters a full amount, the machine will dispense the drug. Okay, so display the balance to pay. After that, the machine will dispense the drug right. Patient can buy only one drug at a time. That is not relevant to the use case scenario description. If he or she has entered more coins, if she has more coins required, more than the required amount, machine will display the balance again. That is for the alternative. Once the drug is dispensed, the machine will print the receipt. Okay. The machine will update the stock details of the purchase of the drug. Right. This will update stocks. And you can take as a last step the patient collect the drug and the receipt. Okay. Yes, you can take the patient entering the full amount, right? Before dispensing the drug. Display the balance to pay. We'll add that. Fifth step here. Pay the full amount. Okay. Right. So then what we have is post condition. Post condition will be successfully purchasing the drug. Then alternative causes. So we had alternative causes where the machine display out of stock. That happens when the user enter. After user enters is select the drug and the quantity. So before calculating and displaying the price, so either that or the machine will display the out of stock. So alternative cause will be 2.A. If not enough quantity, the out of stock, message is displayed. Displayed, and the patient can, that's not 2B. Re-enter amount and repeat from step step 1, right? So if the quantity is out of stock, then the patient will have to re-enter the amount and repeat from the step 1 onwards. Okay. Then the other alternative cause is where the patient enter more coins, right? So that is patient pay the full amount. Okay, so 5.A. The machine dispense the balance. Okay, right. Is that okay for all? So that's the use case description. What is this? Yeah. Okay, so that's a use case scenario for purchase drug operation. Right. So always write the best case scenario for the typical course of actions, and alternative courses, you can put the notes and write down. So if there are more than one option that is given, so you can put as 2A, 2B, 2C likewise, right? If it is only one option, then all the description should be written together. Right? Is it fine? Can somebody reply? Okay. So then you can use a normal line to connect the actor to these use cases. Right? So like this, draw the other things. So I'll just drop the use cases. Then the next actor we have is the pharmacist. Pharmacist can recharge machine, refill, view reports into this. Right, and then add the connections. So to add a generalization, who is Corona? Corona is entering into the meeting, right? So better be careful. Pharmacist is refilling the drugs and operator is refilling the coins. So refill drugs. Okay, so to add the generalization, you can simply draw a line and then change the arrow shape. Okay, then the third actor is the operator. So put operator. So go to the edit mode, you select the symbol and press F2 so that it will make it easier. Operator has 3 operations. First one, refill coins. It's 4 operations, right? Shutdown, sorry, install and repair. So install and startup, and shutdown and repair. Okay. And we have a coin dispenser, right? So you need to show how many objects of those classes are created. Now, to identify that, you need to look at the multiplicity. Okay, so vending machine and the coin dispenser, there is an aggregate composition relationship, and in that, is it composition or aggregation? Okay, so in this relationship, the coin dispenser has a multiplicity of 1, right? That means one vending machine will have one coin dispenser. Okay, so then the vending machine can only create one coin dispenser object when it is when the developers are writing the code. Okay, so that's what we show in the object diagram. So one vending machine object can interact with one display screen object because the multiplicity is 1 here. Okay, so that's what is going to happen in the object diagram, right? So we'll draw the diagram. We go back to the draw IO, right? Okay, so we'll look at the objects first. So here vending machine will have one coin dispenser because it's 1 to, well, the multiplicity is 1 in this side. Then vending machine will have one display screen object. Then vending machine will have one touchpad because here for the touchpad it says multiplicity is 1. Then drug. So vending machine will have multiple drugs. That's why multiplicity is given here as n. So then you can draw few drug objects, right? So we'll say 1, 2, 3 drug objects, and the third one you can say n. And then vending machine will have one receipt printer and one drug dispenser. Okay, so we will show that in. Yeah, so this relationship is actually composition. Okay, so we'll show that in the diagram. Okay, so what I will do is I'm going to represent an object. So you can take the symbol for the object here. right? So I'll put an object, and you can write the object name. So you know there are two ways how you can represent the object name, either as a named object or as an anonymous object. So I'll use vending machine. So this is an anonymous object because I don't have an object name, right? Object name in front. So in front of this colon, I have to give an object name, and you have to underline it, right? And then what I have is I'll have one coin dispenser. So it's going to be another object. One coin dispenser, and you can connect it with a line, just a straight line. Okay. And then have another object that is for the display screen. Another one for, so I'll have vending machine in the middle. Touchpad. Drug dispenser. Receipt printer. Okay. And then can have multiple drugs. So can have multiple drug objects. So I'll have a named object there. So I'm going to name first object as drug 1. It's an object of the class drug. This is going to be drug 2. So if you want, you can give names even, right? Say Panadol, then Piriton, vitamin B, likewise. Okay. Let's say this is the drug N. So this is a named object where I have given names for each object. This is a object diagram. So if the multiplicity is given, like we'll say the vending machine can, vending machine will have 2 display screens, then display screen, there will be 2 display screen objects. You can say display screen 1, display screen 2. So you can't have more than 2 objects there, right? So multiplicity is said as it is 2, exactly 2, something like that, right? Is that fine? So this is an object diagram. So object diagram is very easy because you will be given a class diagram and you have to just look at the relationships and then draw how the objects will be created. Right. Then the next question. Following the description following description gives more details on the patient purchasing a drug. Draw the sequence diagram for the use case purchase drug. Okay. So have you drawn the sequence diagram? So the object diagram, it won't change with the relationship. It only shows how many objects are created which are connected with each other. Okay. Hmm. Okay, so we'll just go through the description first. Says the patient will select the drug and the quantity via touch screen. So first you need to identify the methods and all. So this would be the class diagram. So we have a class for touchpad. That means there will be a touchpad object, and the actor, that is the patient, will act as an actor, right? So patient is actually the actor. So the patient will be interacting with the touch screen. So that means patient will be invoking method in the touchpad. So touchpad has a composition relationship with the vending machine. So when a method in the touchpad is executed or requested, it will run something in the vending machine, right? So touchpad cannot run any method in any other class because they don't don't have any relationship any other class, right? Okay. The vending machine will check whether sufficient quantity is available. If there are stocks available, the machine calculates the cost per drug and display the amount on the display screen. The price of each drug is stored. If the machine does not have sufficient stock, an error will be displayed on the screen. Okay, so you have to identify the methods for each one of those. Right? So the patient can confirm the order via touch screen. So there has to be a method in the touchpad or the touchpad class where the customer can confirm. Then the machine will execute purchase drug operation. So the machine will send the signal to activate the coin reader. So that is activating the coin reader at that point. So that is means we are creating the coin reader there. For each coin entered by the patient, the reader should read the amount and pass the details to the machine. Right? So for each coin entered by the patient, the reader should read the amount. So that is not happening only once, it happens multiple times. Each time when the uh, patient add a coin, this will happen. So it is representing a loop, right? The machine will calculate the new balance and display it on the screen. So this will happen for a loop until all the coins are added. When the coin amount is same or higher than the cost, the machine will signal the coin reader to deactivate. So that's where the coin reader will be deactivated or destroyed. That object will be destroyed. Right, so the drug will be dispensed from the receipt, and the receipt will be printed. Finally, machine will update the stock. Okay, so if the coin amount is not the same, so it has to keep on asking for the coins, right? Right, so there will be a loop, there will be an alternative course or alternatives in the scenario as well. Right, so what we have to do in drawing the sequence diagram is we need to identify which object calls which object's methods and at what time and which method is it. Okay, right. So I'll refer the class diagram, and you take the description and refer the description. Okay, so I need the class diagram, I need the description, and I need the place to draw. Okay, so then let me go back to my diagram. I'm going to add a new page. Right, so I'll change it to a landscape image, landscape screen, so then I have more space. So when you are placing the objects in the sequence diagram, uh, the ones who initiate the communication will come onto the left hand side, right? Okay, so here I have an actor. So your actor should be represented with the actor symbol, and you have to write the name of the actor here. So be patient. Okay, and the patient will have a lifeline, so you can find the lifelines here. See, I have an actor lifeline separate, so I'll add an actor lifeline. Okay, and then the actor will be communicating with the object, which is a touchpad. So you can select the object lifeline and write the name of the object. So that will be the touchpad. Okay. So the touchpad is communicating with the vending machine. So I'll have a vending machine because touchpad has the relationship only with the vending machine, not with anything else. Okay, right. So let me show the first message pass. So it says the patient will select the drug and the quantity via the touch screen. So in the touch screen, there has to be a way to capture that. So there's a method called read drug. Okay, so this read drug method will be called by or invoked by the patient. So in the sequence diagram session, you learn that the actor cannot have returns, right? So actor will not get any returns. So then the actor will be passing a asynchronous message or a signal. Okay, so to show the signal, what you can do is I'll draw an arrow, a message. So you can select this dispatch. Okay, draw a dispatch. So it is invoking a method in the touchpad. So this has to be one side, like half of the arrow head, right? So I'm going to change the ends of the arrow. Okay, so one end will be having a signal one. Okay, and the other end there won't be anything. So I'm going to change it like this. Okay, so this is to represent it is a signal. Okay, and here for the message you can type the name of the method, that is read drug, and you can pass the quantity and the drug. Okay, right, so when that happens, what the touch screen is going to do is it will call a method in the vending machine. Okay, so when the user enter the drug and the quantity, the vending machine, what it will do is it will check whether the sufficient quantity is available. So to check the quantity, so the touch screen will have to call a method in here. So what the vending machine is going to do when the user enter the drug amount and the drug, it will calculate the cost, right? So this will call that method, calculate cost per drug. So when happening that, the vending machine will calculate the or check whether the item is available. Okay, so I'm going to call calculate cost method. So from here, this is going to be a synchronous message, right? This is calculate cost per drug. Right, and make sure that you change the ends. Right, so you have the other symbols, like if you only want a arrow, so here the message and you have the return, right? Okay, and then what happens? So to do this, it will check whether the stocks are available. So for that, if you look at the class diagram, there's a class called drug and there is a method called is available. Right? So this is available will let us know whether the drug is there or not. Okay. So then we need another new object, that is from drug class, and the vending machine will be checking the method of that. Right? So there will be a return. So this checks is available. Right. So if it is available, something happens. If it is not available, it will display it is out of stock, right? If the stock is available, the machine calculate the cost per drug and display the amount on the screen. So there are two paths, right? So that is to show an alternative path. Okay, so then what I have to do is I have to create an alternative. So before that, a message will be displayed on the screen. So I need a object from the display screen. This will be from the class, where is it? Display screen. So to display screen, there is a method called display cost per drug, right? Or display error, right? Either one of those two will take place. Okay, so to show that, I'm going to use a frame that is where is it? Here you can find a frame. This is a frame, so you can drag and drop a frame here to cover whatever the necessary lifelines. So don't drop it onto a lifeline, right? Otherwise it will drag together. Okay, so I'm going to write here the first one, if out of stock, if the drug is out of stock, what will happen is the vending machine will call the display method, sorry, display error method in the display class. Oh, what happened? Okay, so show the activation. Okay, right, and then if it is not out of stock, then that is going to be another frame. So I'm going to add a new frame. This is if in stock. Okay. Then what should happen is it should calculate the drug. So to calculate the drug amount, it has to take the value of each drug, the price of each drug. Right. So we are in the calculate drug per cost. Sorry, calculate cost per drug. So there's a method called get price. So it will call the get price method in the drug. I think I should draw it and then put the frame. That will be easier. Yeah. So when you are drawing it, put the frame late. You draw the messages and then you put the frames. So find an easy way to draw it. So then it will be easier. This is the get price. So this will send the price. Right. So it will get the price, calculate the cost. So we are in the calculate cost per drug method. So it will calculate the price and then display the amount in the screen. So it will call, where's the method? In the display screen, there's a method called display cost per drug. So it will call that method. So for these display methods, a return is not much important because the screen won't send any response, right? Display cost per drug. Okay, and then what I'm going to do is I'll put a frame here because all this happens if the item is in stock. Okay, so up to this point, is it okay for all? Where's the chat? No, for your question, Arya, no. The actor interact with the touch screen, right? Touch screen will call the methods in the vending machine. Okay. So actor will not be interacting with any of these classes. Vending machine, these are classes. The vending machine is a class, not the device, right? So device is represented by the, here the touchpad will represent the way how the outside interact with the machine. So vending machine is a class which runs the operations. It's like the control class. Vending machine is a controller class. Drug is an entity class. Display screen is again an entity class likewise. Or no, display screen will be a controller class where it will display something. Okay. So when you are drawing it, right? So now this is my first time drawing the sequence diagram in ROIO. So see how much time I take. So make sure that you draw the diagrams and get used to it, right? So then you will find shortcuts, doing things and all. Okay, so make sure that you draw a few diagrams and then get used to the drawing of the tools. Okay, so then what happens? So out of stock, that is done. Then after that, what the patient has to do is, it goes to the description. Machine calculate and display the amount. The price of each drug is stored. If the machine does not have sufficient stock, we handle that. The patient can confirm the order via touch screen. Okay. So this vending machine calculate drug per cost. It's a method which will have a return. So I need to show the return. Okay. So after all this happens, so the lifeline of the vending machine will actually be lengthier than this. So I'll just draw it down. Same goes with the touch screen. Touch screen activation is so for this method call, there will be a return. You have to name the return actually. So once that return comes, the actor can confirm, right? So again, the confirmation is going to be a signal. So like this. So I'll copy that. Say copy and pasting works. Yeah. So it worked. So I'm going to pass a signal. This is to confirm the order. So there's a method in the touchpad class called confirm order. Right? So the user will be invoking this method, confirm order. So even though this calculate cost per drug method has a return, the touchpad will not send a return to the actor. Right? So you remember that the actors will not get return. So that's why we pass signals. So this is to confirm order. Okay. And once the order is confirmed, what's going to happen? Then the machine will execute purchase in drug operations. So then when the order is confirmed, what the touch screen is going to do, so the touchpad object will call purchase item method in the vending machine class. Right? So then that is another method call. So where this is going to call purchase drug. Okay. So what happens when the purchase drug is called? The machine will send a signal to activate the coin reader. Right? So at this time, the coin reader object will be created. So here, this is the vending machine's lifeline. So purchase drug method is called. So then what happens is it will make the object for, where's the object lifeline? Coin dispenser. So this object will be created at this point. So there's a type called a create message. Destroy is okay, so this destruction is there, but it does not show the creating one, so we'll make it like this. So it's a signal, so you need to change the ends. Right, and then what happens? It initiates it. For each coin entered by the patient, the reader should read the amount and pass the details to the machine. Okay, so it should read the details and pass it to the machine. So what happens in, so what are the methods in the coin dispenser class? Coin dispenser have validate node, read note amount, calculate coin amount, dispense coin, refill coin. So it will be calling calculate coin amount method, which is a self message. Okay, so here there's the self message. Sorry, not a self message. Yeah, it will be a self message. Are you in? Question 3. Anyway, we'll go through that, will you? So it says describe the CRC cards and their importance. So just refer the lecture slide, you will find the information. So I'll not discuss the straightforward ones. State difference between aggregation and composition relationships. So it's a whole part relationship where one says the part should be part can exist on its own. The other says the part cannot exist without the whole. Okay. And then you're given a description. It's about managing projects, right? So you have to read that description and list the nouns in the above scenario. For each noun, state whether it is a class in the system or not. If it is not a class, state the reason. Right? And then you have to draw 2 complete CRC cards for the 2 identified classes. For 2 identified classes in the above scenarios. You don't have to draw it for all. You can draw it for 2 classes that you have recognized and draw the complete class diagram for the other above scenario. Okay, right. So first we'll do the noun verb analysis, and you have to list down the nouns and then identify whether they are classes or not. Okay, right. So have you read the description? Okay, so the nouns in this one is nouns in this one are take. Okay. Right. So we have the nouns software. So first we'll describe, read it. So the software company needs to manage information regarding many projects that they are engaged in. Following are some of the requirements. So you can ignore the first sentence because it is describing what this scenario is about. A project manager is responsible for managing projects, and every project has one project manager. A manager could be assigned to could be assigned to many projects. A project About a project, details such as project ID, name, description, start date, and all are stored. A project manager can manage the budget, schedule, and update the progress of the project. So those are the operations or the responsibilities of the project manager. A project consists of many tasks. A task belongs to exactly one project. A project cannot exist without any tasks. A task is described using the task ID, description, task date, end date, duration, and the predecessor tasks. For an example, task gather requirements. So that is describing information about tasks, right? For an example, task gather requirements should be carried out first before the task design the system should start. Therefore, gather requirements is predecessor for design system. A project manager can add, delete, and update tasks for a existing project. A team member is described using the member ID, member name, qualifications, skills, and experience. A team member can be the project manager or a member of the team. Project manager can assign tasks to members and check their workload. A member of a team can view their workload and update the progress of a task. All members needs to log into the system using username and password to access and update the project details. Any team member, project manager, or the member can log and view the progress of the tasks and overall progress of the project at any time. Okay, so what you have to do first is list down all the nouns and then determine the whether they are classes or attributes or what. Okay, so I will ignore the first line because it's about description. Hmm. Okay, so from the second para onwards, you have project manager, then is responsible for managing projects. Project is another noun. Project manager could be assigned to many projects. About project details such as project ID, name, description, start date, then end date, budget, duration. These are the nouns of stored. A project manager can manage the budget we have taken, schedule, and update the progress. So progress is a noun of a project. A project contains many tasks. So task, a task belong to exactly one project. So project we have already taken. A project cannot exist without any tasks. A task is described using task ID, description, task start date, task end date, duration, predecessor task. I'll just call it as predecessor. Predecessor. A predecessor task should be carried out first in order to start the certain other tasks. For an example, task gather requirements should be carried out first before the task design the system started. Right. A project manager can add, delete, and update tasks for existing projects. Team member. It's another noun is described using member ID, name, qualification, skills, experience. A team member can be a project manager or member of a team. So member, project manager can assign tasks to members and check their workload. A member of a team can view their workload and update the progress of the task. All members need to log into the system using username. Username is another noun. Password to access and update the project details. Project details. Any team member, manager, or member can log in and view the progress of the tasks and overall progress of the project at any given time. Okay, so these are the list of nouns. Now what we have to do is we have to go and check whether they are objects, sorry, whether they are classes, attributes, or we are going to discard them, right? Okay. Right. So project manager. So does the project manager has responsibilities or the things that the project manager should do, operate? Yeah. So therefore we can take the project manager as a class. So project manager is going to be a class. Project. So we are not, project is not supposed to do anything, but we are storing the project details. So then the project is going to be a class which is actually a storage class, which is an entity class. So project is going to be a class. Then project ID, name, description, start date, end date, budget, duration, schedule, and progress. All these are attributes of the project class, right? So I'll color them with say blue. So whatever in blue, all these are attributes of the project class. Right? So whatever I have highlighted in blue, all these are attributes of the project class. Okay. Right. And then if you take a task, so task again like a project, it will store the details of the tasks, right? So therefore this is going to be a class. It's an entity class where it store the project task details. So task ID, description, start date, end date, duration, predecessor, all these are attributes of the task class. Okay, so whatever in yellow, they are attributes of the class called task, right? Okay, so then we have another class or another noun which is called team member. Okay, so team member is another class, and member ID, name, qualifications, skills, experience, these are attributes of the team member class. Okay, so whatever in green are attributes of the team member class. Then member, it is a class, and this is a subclass of team member. Okay, so same goes for the project manager. So project manager is a class, but this is a subclass of team member, because in the description it says a team member is either a project manager or a member. So team member can be the project manager or a member of a team, right? So we have a class called team member, and we have two types of team members, either project managers or just member. Okay, so these username, password, these are also attributes of the team member class. Each member will have a password and a username. So I have highlighted them in green. Then project details, you don't have to take this because it is same as the details listed under project class. So project details are the project name, ID, and all, right? Progress likewise. And overall progress, again we have taken, right? Progress is taken. So whether we say overall progress or progress, it is representing the progress. So we don't have to take this separately. Okay. Is that clear? Budget is not a class, right? So budget is an attribute of the project class. Managing the budget is a responsibility for the project manager. Right? So when we will draw the CRC card for the project manager, then you will see it's an operation, or actually a responsibility, to do the modification to the budget. Okay, is that fine? That's the chat. Okay, so second part of it is to draw two complete CRC cards for the identified two classes. Right. So I will do this. I'm going to write the CRC card for the project manager. Okay. So the class name, project manager, and here I'm going to list the responsibilities and here the collaborators, right? So what are the things the project manager should do? Project manager is responsible for managing projects. So that is manage project. So as a collaborator, we need the project class. Okay. Because to manage the project, we need to access the project details. Okay. One responsibility is that. So project manager could be assigned to many projects. That's not a responsibility of the project manager. So it is something that the project manager can do. So when you draw the class diagram, that piece of information will be useful for you. Yeah, so project manager can manage the budget, schedule, and update the progress of the project. That is called managing the project. So manage project by updating budget, schedule, and progress. Okay. A project consists of many tasks. The tasks belong to exactly one project. The project cannot exist without any tasks. Uh, okay, so this predecessor task should be carried out. That is to fill some information and to make you confused, right? Right. So project manager can add, delete, and update tasks. Right, so add, delete, and update tasks. So to do that, we need the task class as a collaborator. A team member is described. Project manager can assign tasks to members and check their workload. So assign task to members. That's another responsibility. And check member workload. So we need task and member. So to this we need the member class. All team members needs to log into the system. So log in. Update project details. We have already written that responsibility. So to log in this, there are no collaborations needed. And view progress of the tasks and overall progress of the project. So we need view progress, say view task progress, and view overall progress. So to view the task progress, we need the task. To view overall progress, we need project. So we're not specifically mentioning what are the operations, it's just the responsibilities as a description and what are the clauses that needs to fulfill that responsibility. So we wrote one CRC, so you can select any and type the second one. We'll say I'm writing it for the task. Okay, so the task clause responsibility would be maintaining task details. So if you want to be specific, you can say add tasks, add, delete and update. So for that, you don't need any collaborations. It's just storing. You can say either storing or maintaining. So if you are listing down the project class, then again it will be something similar, right? So it's an entity object, sorry, entity class where it store the project details. If you are listing down the responsibility card for team member, then there will be operations like other ones, like viewing the workload. Let me try that as well. CRC card for member. So this will store member details. Apart from that, it will view workload. So for that, we need the task and update progress of a task. Again, we need the task class for that responsibility, and also they can log in system. No need of a collaborator for that. View task progress. And view overall project progress. Same as these two. Paste. Okay, is that fine? So are you all sleeping? Right, so that's what we did. So we took the team member, and team member will have two subclasses, project manager and member, and so they are connected with extents. And we have the project and the task, where project has the project ID and all the methods that you can take, and task is there. So it says the project cannot exist without a task, so we had a composition relationship between them. And the project manager will be managing many projects. A manager can manage many projects, so the multiplicity is many. A given project has only one manager, so therefore the multiplicity is one here. And project manager can assign tasks, so therefore you have the relationship, the association. And a member can be assigned to tasks, so a task will belongs to a member or will be managed by, handled by a member. So there's an association relationship between task and the member. So that's what the that's how the class diagram will looks like. Okay, right. So then what you need to discuss? What else? Okay, right. So in the deployment, so first you again like the sequence, sorry, like the use case, what you can do is read the description. Okay, so we'll read the description together. Basecamp is an online project management system. The user of this system are project managers and team members. The user can log in using the browser component, right? So then we found something called component, right? So browser component running in his or her PC. So it runs in a PC, tablet or smartphone, and access the system from anywhere at any time. Basecamp system is composed of many software components. BC component is a main software component which the user connects. BC component is running in the web server as a place where it runs. The browser component, that's another one. Browser component uses the services of BC component via BC1 interface of the BC component. The project details are stored in the MongoDB database. So we have a database. The database of the system is running on a server in the cloud. The web server is running on a separate Apache server. So we have a web server and the name of it is Apache server. The web server is using the services of the database via DB1 interface of the database. So the database have an interface. Database component has a interface. Users can chat and exchange information using the system. The chat service component is running on a separate server in the cloud. So we have a cloud server. The BC component, the one that we saw earlier, is used in the services of the chat service. BC component connects to the chat service via CI interface of the chat service component. So chat service component has an interface called C1. Project reports and details can also be printed using printer, which is connected to the user's PC via a local area network. Okay, right. So deployment diagrams are very easy. The first thing you need to identify is what are the components, okay, and where those components run. Right, so the running place are the deployment places. First identify the components and then identify where those runs. Okay, so let me write it in this Word document. So we have several components. Okay, so the components are right. So component, we have a browser component. So browser component runs in user's PC, user PC, tablet, or whatever it is, right? And then the Basecamp system composed of many software components. BC component is the other one. BC component. Do we have BC component? BC component is the main software component which the user is connecting to. So it runs on the web server, right? So this runs in the web server. Okay. So what I identify as the server, the running place is the actually the device or the hardware. Okay. So again, web server is the hardware, right? The browser component uses, that means the browser component is using the BC component via BCI interface. So this has, so BC component runs in the web server and it has an interface called BC1. Okay, so about the BC component, it has an interface and it runs in the web server. And browser component, this uses the BC1 and it runs in the user's PC. Okay, right. What next? The project details to be stored in the MongoDB database. So we have a database component. Database component which runs in a cloud server. So this runs in a cloud server. Okay. The web server is running on a separate Apache server. So we had information about the web server. So the name of this is Apache. Apache is a server name, right? Which runs basically Java services. Okay. The web server is running in the services of, the web server is using the services of the database via DB1 interface. So database component has an interface, and the name of the interface is DB1. And who is using it? The web service. What is the web service? That is a BC component. So BC component has an interface and also it uses the DB1 component. Uses the DB1 interface. Okay. Right. Users can chat and exchange information using the system. The chat service component is running on a separate server in the cloud. So there's a chat service component. This runs in a separate cloud server. Right? So it's not the same server as where the DB server is running, right? The BC component is using the services of the chat service through CI interface. So this has an interface. So chat service component has an interface which is C1, right? And who is using that? The BC component. So BC component uses C1. Project reports and details can be printed using the printer which is connected to the user's PC. So user's PC is connected to the printer through LAN. Okay, so this is the summary of that description. So prepare something like this. While you read it, you prepare something like so. Then you can easily identify, right? I have a component where it runs and what it is using, right? Or who is using it. Okay, and then you can put this into the diagram. So you know the components. Between the components, there are two types of relationships. If a component is using a interface of another, then it is a dependency. If a component has an interface or provides an interface, then it is the interface realization relationship. And the nodes, so the places where these components runs will be the nodes. So we have two types of nodes, either a processor node or a device node. So if the node is performing some operation, then it is going to be a processor node. So for an example, if you take this user's PC, that is going to be a processor node because there's a component which is running. But if you take this printer where the user's PC is connected, then the printer is a device. So nodes are of two types, either no device or a processor. Right? So you just have to identify. So some nodes can be labeled or named, or some may not be named. So for an example, if you take this web server where the BC component is running, it is given a name called Apache. But if you take the chat service, if you take the cloud server where the chat service is running, that is not given a name, right? So it's an unnamed cloud server, which is a processor, right? It's a deployment place. Fine. So that's what we're going to show in the diagram. Okay. So I'm going to use this and draw the diagram here. So let me add another page. So is this part okay for all? Identifying the components and identifying where they run and all. Is it fine? Okay. Right. So then what I will do is I'm going to draw that in here. Okay. So right. I'm going to use a component. So first, let me drop a node. So you can use the block here to represent the node. Okay, so I'll use a block. So give the name. So here I have the user PC. There's no name given for the user PC, so I'll just use it as a so this is going to be a processor. Okay. Okay, so then you have to put the component inside it. So there are actually two ways how you can represent a component, either using this method. So since you are familiar with this, I will use the given component method. So the name of the component is BC browser component. and then we need another one, that is the web server. The name is Apache. It's a web server. So this has a component that is called BC component. Right, and it has an interface called BC1. Uh, so this provide us the newer notation. So what you can do is make it. Right. So the name of this is going to be BC1. Okay. And then it uses the DB1 and uses C1. So we have not yet drawn them. So I'll draw the node for the DB. This is the cloud database server. So there's a component called the database component. So the name is given as MongoDB, right? So you can write it here, MongoDB component. So it has an interface. Right, so give the name of that, which is DB1. right? So BC component uses the DB1 component. So then you have to show that using the dependencies. So this BC1 uses the DB1 component. So that's the dependency relationship which you can use for it. Right, so like this you can draw. So I'll show you how to show that the PC is connected to the printer. So you can add a node, and that will be a device. This is which is the printer, and then this will be connected via the LAN. So between PC and the printer, so printer will be connected to the LAN, and the PC will be connected to the LAN. So web server, database server, these are cloud servers. Okay, so they are connected through the cloud. So you can show the connection. This is connected through the cloud. So you can write the name here, sync cloud. Okay, so this is not the complete diagram. There are other things to be represented, but it's similar, right? So you can put the node, can put the component and show how it is. So this one is the interface realization, and this is the dependency relationship. Right? So I think the difficult part is coming up with this summary. Right? Identifying what is a component, where it runs, and then putting that into the diagram is not that much difficult. Okay, so if you are given the diagram and asked questions, then you should be able to ask. Like for an example, assume that I give you a diagram like this and then ask, okay, which interface is used by the DB database component? Then you should say, okay, you should be able to identify that it is using the BC1 interface. Okay, so if I ask a question like, okay, what are the interfaces provided by the BC component? Then it should be, you should be able to identify them and write them down. So what is the name of the web server? Then it is the Apache server. Right? So how the web server is connected to the database server? Okay, it can be a cloud connection, or it can be through a LAN, or it can be a VPN, through Wi-Fi, whatever it is, right? So by looking at the diagram also, you should be able to answer. So it's same as drawing it, right? So if you know how to interpret a diagram, that means you know how to draw the diagram also, right? So it may not be only drawing diagrams always, right? So don't be uh, misled by that. So you should be able to interpret a diagram also. So does it answer your questions? So can I have a feedback from you? Others? Do we have others in the session still?